Hello everyone. In this lecture, we will discuss about the introduction regarding the sequencing problems. Sequencing is the optimal order which shows the minimum time for the resources to give the low cost and high utilization of the resources. Here, resources are the jobs, equipment, people, material, facilities, etc. An objective of the sequencing is not only find the optimal order, but also calculating the optimal production schedule or minimizing the customer's waiting time for a product or service, meeting promised delivery dates, keeping stock levels low, providing preferred working pattern, and so on. Let us consider n number of jobs, that is the small n, processed on the m machines, yes, small m machines, which know the all processing time for the jobs on respected machine. Then possible sequences are the n factorial whole to the power of m. And we have to see the some terminology and notations used in the sequencing problems. First terminology is the number of machines. It means the service facilities through which a job must pass before it is completed. Second terminology is the processing order. It refers to the order in which various missions are required for completing the job. So next terminology is the processing time. It means the time required by each job complete a prescribed procedure on each machine. Next we have to see the next terminology, that is the ideal time on machine. So this is the time for which a machine remains ideal during the total elapsed time. During the time, the machine await for completion of manual work. Here, the notation Xij is used to denote the ideal time of a machine J between the end of the I minus 1 to the job and start of the ith job. So next terminology is the total elapsed time. This is the time between the starting the first job and completing the last job. So which also includes the ideal time. So total elapsed time is which is including the ideal time as well as the total processing time. So next one is the no passing rule. It means passing is not allowed. So here we are maintaining the same order of the jobs over each machine. If each of n jobs is to be processed through the two machines, let us consider M1 and M2 in the order of M1, M2. Then this rule will mean that the each job will go to the machine M1 first and then to the machine M2. If a job is finished on M1, it goes directly to the machine M2 if it is free. Otherwise, it starts a waiting line or joins the end of the waiting line if one already exists. Jobs that form a waiting line are processed on machine M2 when it becomes the free. So these are the no passing rule conditions. Next we have to discuss the some assumptions in the sequencing problems. First assumption is the no machine can process more than one operation at a time. Second one is the each operation once started must be performed till completion. Third assumption is the each operation must be completed before starting any other operation. Fourth one is the time intervals for processing are the independent of order in which operations are performed. And next assumption is the there is only one machine of each type. So next one is the job is processed as soon as possible, subjected to the ordering requirements. So next assumption is the all jobs are known and are ready for the processing before the period under consideration begins. Last assumption is the time required to transfer the jobs between the machines is negligible. So these are the assumptions. So next we have to see the what are the different types of the sequencing problems. Here mostly we have to discuss the four types of the sequencing problems. First type is the n number of jobs, that is the small n jobs with the two machines. Second type is the n number of jobs, that is the small n jobs with three machines. So third type is the two jobs with the n number of machines, that is two jobs with small n machines. And last one, fourth type is the n number of jobs, that is small n jobs with k number of machines, which means fourth one is the n jobs with k machines. So these are the types of sequencing problems. Thank you.